So take your coffee, your water, and have a seat. Nie widzę Asi. Asia gdzie jest? Jeszcze mam takie... Ola. Gdzie Aśkę będzie widać? This is the first time here, so it takes a while to get ready. Hello, everyone. It's nice to see you. We have beautiful weather today, and I'm really glad that you came to see our finalists, our great PhD students. I wrote everything on these cards because in English it's a bit more difficult to present. So I'm very happy to see so many people who came today. And my name is Aleksandra Ziembińska-Buczyńska, and I will have the pleasure of hosting today's event. The competition in English language formula is held at Silesia for the first time. We decided to do this competition because we have 80th birthday of Silesian University of Technology, and that's why we would like to also celebrate with our PhD students this anniversary of our university. So far we have organized Polish version of this competition. It was 7th time last year, and this year again it will be in Polish in fall. The organizers, the Silesian University of Technology, on behalf of this organizer, I represent Science Popularization Center. We also collaborate with our doctoral school and the doctoral students' self-government. I would like to welcome very warmly our hosts, mainly the rector of the Silesian University of Technology, Professor Marek Pawełczyk. Welcome. I also have a great pleasure to welcome Vice Rector for Students Affairs and Education, Professor Anna Chrobok. The second Vice Rector who came for our event is Professor Sebastian Werle, Vice Rector for Science and International Cooperation. I would like to also welcome the headmaster of the doctoral school, Professor Krzysztof Ujarewicz. And the representative of the doctoral students' self-government, Klaudia Cholewa. I also have a great pleasure to welcome again Agata Wojcik. She represents our sponsor of the Engineering Award, EMT Systems. Hello. And Professor Marek Łos, representing the founder of the additional award, the European Journal of Pharmacology, published by Elsevier. Welcome. I would like to welcome the jury, wonderful jury, very serious face here, Professor Edyta Sierka, Professor Tomasz Francuz, Dr. Jakub Bochiński, and Dr. Joanna Bagniewska, who is online with us today. Hi, Joanna. And of course, I would like to welcome the promoters of our finalists and the finalists themselves, with all wonderful guests who came here to listen to the absolutely amazing science stories. Welcome warmly. A few words about the prizes. The first, second, and the third places and the audience award were founded by Silesian University of Technology. The engineering award was founded by EMT Systems, and the financial prize was founded by European Journal of Pharmacology by Elsevier. The patrons of today's event are the Council for the Dissemination of Science of Polish Academy of Science, Polish Association of Doctoral Candidates, Eureka Pro, and the University of Queensland, Australia, who created the 3-minute thesis formula. The competition came us from Australia to Silesia and to Poland. We have already organized 7 editions here, and the formula is very simple. A doctoral student has 3 minutes to present their doctoral dissertation in an accessible and clear way for a wide, non-scientific audience. He or she can use one static slide and for this purpose, but not any other kind of props. Again, serious face of one of the finalists. Please smile, it will be a really nice competition. The jury, whose composition I will present in a moment with the full description, evaluates both the way of presentation and its substantive content, and they will indicate the first, second, and the third place in the competition. You guys who came for this competition as audience and support, you have your own prize. This is the audience award, and when you've been entering this event, you got the card on which you can write down the name of your own candidate. We will collect these votes after the presentation of the finalist, and it will be your choice. And time to present our jury. Professor Edyta Sierka, she represents the University of Silesia. She is a biologist, environmental protection specialist in the field of functioning of urban industrial ecosystems. She implements numerous forms of cooperation with the university environment, including elements of citizen science, project commissioned for local government units, and activities for children's university. Thank you very much for coming. It is really great pleasure to have you here. The second, Professor Tomasz Francuz, he represents Medical University of Silesia. He is a specialist in internal medicine. Professionally and scientifically, he is interested in lifestyle diseases, especially diabetes and its connections with the development of cancer. Active science popularizer, involved in a variety of projects in this field. He is particularly close to the combination of medicine and computer science. Welcome, Professor. Professor Joanna, you are already professor here. PhD, Joanna Bagniewska, she is linking with us from Oxford University. She represents Oxford University and Oxford Graduate School. She is a zoologist and a science communicator. As a departmental lecturer in environmental sciences at Oxford University's Department for Continuing Education, she splits her time between directing the postgraduate certificate in ecological survey techniques and teaching at Oxford's Graduate School. Oh my God, it was difficult. Her academic interests include conservation biology, behavioral ecology, and citizen science. In her spare time, Joanna works as freelance popular science writer, presenter, and communicator coach. She is also a FameLabber and TEDx performer. And last but not least, Jakub Bochiński, also PhD. He is also a FameLabber and TEDx performer. He works on the development of space technologies at Creotech Instruments, serving as Deputy Director for Space Products. He has led research and development projects aimed at designing new space missions and innovative satellite systems. He has previously worked at University College London and the Open University at the United Kingdom. In Poland, he managed R&D teams at the Copernicus Science Center and Solars Consulting. He actively shares his experience as a public speaker, including Adamet Smartup, InfoShare, Women in Tech Summit, and BBC Stargazing Live. Welcome. These guys are going to give our finalists the feedback, also in merits and the performance. So I wish you luck, guys. It will be very tough. And now, ladies and gentlemen, it's time to present our finalists in the order of appearance. And please forgive me my mispronunciation of the names, because I have terrible problem with foreign names. I have already asked how to pronounce some, so please be gentle. And now I need a list. Thank you very much. The first will be Mamubech. Yeah, okay, Kawusi. Yeah, thank you. Silesian University of Technology. This is our first finalist. Please welcome her very warmly. The second one is a representative of University of Economics in Katowice, and this is Hoat Hidiem Nguyen. Was it okay? Yeah, thank you. Of course, warmly welcome. The third person is, it will be easy, Patrycja Janiszewska. Medical University of Silesia. Where are you, Patrycja? Yeah, hi, welcome. Number 4 represents Silesian University of Technology, Magdalena Ćwiertniewicz-Wojciechowska. Polish, but still difficult. Number 5, we have Ravi Shankar Yadav, also Silesian University of Technology. Number 6, we have also Silesian University of Technology, and it's Kosmos Łozoma. Hey. Number 7, Medical University of Silesia in Katowice, Jakub Pniak. Number 8, also Medical University of Silesia in Katowice, it will be Kamil Monkosza. And the last but not least, Humam Ahmed, Silesian University of Technology. And now I would like to ask our rector, Professor Pawełczyk, together with Professor Fujarewicz from doctoral school and the representative of our PhD students to join me and say a few warm words to our candidates.
Good afternoon. I would like to start from appreciation to the director of this Center for Popularization of Science. You are organizing this not for the first time, but this is for the first time for our international community, I would like to say, because this is not only for the international students, because also some Polish students, PhD students take part in this competition. And I don't know who already had the chance to participate in the one which was organized in Mrowisko for Polish PhD students, but it was very, very inspiring. I had the pleasure to participate several times in those contests, but always I would like to say that I am very much impressed about, first of all, the knowledge, the work, the scientific achievements, and the way of presentation. And also the way of discussion with the jury, which is very, very spectacular. Yes, yes. I would like to wish you fast development of your career. Perhaps for some of you, today's presentation will make a rapid change because you will present it to not very large audience, but those who are very much interested about your achievements and those who will appreciate this and take in their minds to perhaps forward to somebody else. And I wish you successful completion of your PhD and wonderful career. You are always very much welcome in the Silesian University of Technology. Thank you very much. And I would like to thank my vice rectors, please show up, who participate today. I will not be able to stay to the very end, but perhaps they can. So. Yes, at least Professor Verle. Thank you very much again.
Good afternoon, everybody. I'm here on behalf of the PhD Candidates Council, and today I would like to say that we are very proud and happy to be here and help organize this event. And it's very, very, I'm very, very grateful to be also here and look at these great opportunities to maybe see some interesting topics in the more simple and interesting ways. So the 3-minute thesis is, of course, the great opportunity to maybe see something different in the simple way, and that's not easy to show it that way. And I wish good luck to all of these competitors, and of course we are here for you all of the time. So thank you so much.
Okay, my name is Krzysztof Fujarewicz. I'm head of doctoral school. And as you know, this is not the first time this event previously was led in Polish. This is the first time when it is given in English, and this is also the first time when where the doctoral school is a co-organizer of this event. So we are very proud to be a part of this event. And what I can say to competitors, simply I wish you good luck. We hope we will give the prize for the best competitor.
Thank you very much. Thank you very much. Thank you, Rector. Thank you, Professor. Thank you. And now we have the first person on the floor. And again, I have to work on the pronunciation. Mahbubeh Kavosi from Silesian University of Technology. She is the first candidate for the prize in English for Minute Thesis. The floor is yours.
Thank you.
Yeah, warm her up. Please warm her up.
And can I start?
Yeah, you have the timer there. You can see the timer. There, where the colleague is. Yeah.
Oh, okay. Years ago, one of my friends had a surgery. The operation went well, but the scar it left behind was thick and painful. She used to joke that looked like her body overreacted to the healing. At that time, I laughed too, but now as a researcher, I realized that she was true. Healing is not just a process, it's a conversation. Conversation between cells and their environment. Hello, my name is Mahbubeh Kavosi. I'm a PhD candidate in biomedical engineering, and today I'm taking you into the world of healing through the eyes of your own cells. Imagine you cut your hand. Inside your body, a group of superhero cells called fibroblasts rush to the wound area to rebuild the tissue. In fact, fibroblasts are builders of your body, which produce some materials like collagen to help the cells to make a best ECM stiffness. ECM stiffness, but they need two things: a stable environment, which is called extracellular matrix or ECM, and a fascinating cleanup process called autophagy. Think of ECM as a scaffold supporting cells or workers, and autophagy as a recycling machines which help cells to be healthy and efficient. But what exactly happens if this balance is lost? If the ECM becomes too soft, cells over-rely on autophagy. Therefore, the wound never heals. This is a chronic wound. On the other hand, if the ECM becomes too stiff, autophagy shuts down and wound heals too much, forming thick and painful fibrotic scars. But now imagine that we can talk to cells by changing how the environment feels. That's exactly what I'm doing in my PhD project. In the lab, I simulate different ECM stiffnesses by using a smart combination of materials like polyethylene glycol and gelatin, like designing custom matrices for cells, each with different bonds. Interestingly, this is the first time such a system is being used to study how ECM stiffness can control autophagy and in turn wound healing. If we can understand this language, that how cells sense and feel different ECM stiffnesses, we can rewrite the story of wound healing. Thank you so much.
Please stay. Thank you very much. Perfect timing. I was showing here, but we'll just put this here because our PhD students cannot see it. Dear jury, comments. Who first? No. The most experienced.
I don't know if I'm the most experienced jury member here, but I will try to do my best, of course. So obviously we're a little bit nervous, so it's perfectly understandable, I think. Maybe the slide, don't you think that the slide maybe were a little bit overcomplicated? You use a lot of very sophisticated words. And can you say, just in two sentences, using two sentences, simply, what is the aim and what is the goal of your research?
And the goal of my research project is that to simulate ECM stiffness by using some materials to mimic the exact stiffness of ECM in the cells.
Okay.
Because of different responses of cells, different responses to different stiffnesses, which is involved in cancer, in wound healing, and fibrotic responses.
Yeah, but it's a very broad spectrum of topics. So it's you are mainly focused, for example, on the wound overgrowth, or maybe cancer progression and metastasis, because it's the molecular
Yes.
processes are pretty much similar. However, this is something absolutely different.
Yes. In this stage, I'm focused on wound healing,
Okay.
but I would like to expand my project for using lung cancer disease, which is involved in ECM stiffness in different kinds of cancer, lung cancer.
Yeah, thank you very much.
You're welcome.
I have a quick question. So I'm not from the medical field, so my question would be a sort of a very natural one. When could it help me? So I suppose if I fell sick, then if your research is successful, it will help me come back to health somehow better. Can you explain how this is going to have an impact on me potentially?
To be honest with you, a significant number of people around the world suffer from these wound healing malfunctions, like diabetic persons or some people who suffer from fibrotic tissues. And if we can manage these ECM stiffness in complying with autophagy, we can open a new door to the window to the healing story. Do you know? Maybe we can suggest smart therapies, and maybe by using some kinds of smart materials and with the help of biology.
Is that the only approach? Are there different approaches, but this is just a better one potentially?
Exactly. Maybe by inhibition or by inducing autophagy and controlling ECM stiffness in parallel.
Fantastic, thank you.
You're welcome.
So, what is autophagy?
Autophagy is a process in which cells recycle damaged organelles or misfold proteins and convert them into the healthy things and make cells more healthy and be more efficient. Do you know? And whenever cells feel low energy or high energy, autophagy is like a motor or like a regulator, the energy regulator of cells, and it make a balance in the energy of cells. Yes.
Thank you.
You're welcome.
Joanna, any questions?
Well, just a very quick one. I must say I really enjoyed the talk because since I'm not in the field, I already feel like I've learned something new. So that's really great, and you've explained all of the jargon. I was wondering at what stage your research is at. How far along are you in your doctorate? So have you already seen any results from your work, or is it at a more preliminary stage?
Exactly. In this stage, I reached some preliminary data by modulating autophagy, by using some pharmaceutical modulators like bafilomycin and rapamycin. I use these autophagy modulators to make a baseline characterization of fibroblasts, which is very essential for my works to make a clear reference point to make a better interpret of our results. Do you know fibroblasts create impact in during wound healing? If we can make a best baseline for characterization of them, it would be very worthy for my, valuable for my work. Yes. In this stage, I just characterize my two human foreskin cells, and I modulate autophagy in these cells.
Great, thank you very much.
Thank you very much. One more time, thank you very much for the presentation and for all questions from jury. Please warm her up again. Thank you very much.
Thank you.
You are very shy, audience. You should be more enthusiastic. I know it's Friday afternoon, so it's difficult sometimes to be enthusiastic, but we have such a nice PhD students with so great topics. So now I would like to welcome the second person on our floor, Hoatidiem Nguyen, University of Economics in Katowice.
Yeah,
Here you can see the timer, and we'll start for minutes.
Yeah.
Okay, so good afternoon, everyone. I'm so delighted and honored to be here in this finalist round. So welcome to my note today about thriving through turbulence. I purposely created this picture about the ship on the stormy sea where the wave crashing, the thunder roaring, and it's can metaphor for doing business to every company, especially during the tough time. Yet the ship is represent for the company, and the storm is about pandemic crisis or economic downturn. So what the company can do during that unstable time, we're looking at resilience. So resilience is like the ship built. It's just how strong the company structure or how well the crews on the ship or the team in the company can work well together under the pressure. And with the understanding of how well the team can work, we can create the more opportunity for the team to working on. And resilient company not supposed to sink. Actually, they're supposed to stay afloat. And how can they stay afloat? The company should follow the wave, the market conditions, adapt themselves and adapt to the market so that they can move on with the business. However, being strong or resilient is not enough. They require a captain, a manager, or even the leader with the courage, the one who can strong to change the course, or someone who can willing to take a risk, spot the opportunity proactively, or using all the available sources innovatively to their business. That's we call the spirit of entrepreneurship, or we can say it entrepreneurial orientation. And so that's why, and together with resilience and entrepreneurship, it has impact on the firm performance. It's not only about the survival, it's about moving forward. It's about looking at the future, the long-term future succeed and to overcome the difficulty. The main idea for my topic is to explore how the entrepreneurship can boost the power of resilience in terms of business performance. It's like as in the will to the sail, and also not helping the company not only to weather storm but keep moving forward. And what can we take away from the idea? Either we are running the business, leading the school, managing the project, or even building our career. Being resilient or bounce back is important, but how we bounce forward with the creativity, boldness, action, that will lead to our long, successful journey. And thank you very much for your listening today.
Thank you very much. Again, perfect timing. Thank you. Dear jury, who is now starting? Maybe Joanna? You will be the first one asking questions.
Okay,
Yeah.
great. Thank you very much for this talk. I was wondering, what are the next steps from this? So would you be able to, on the basis of your finding, provide some guidance to companies? Is it a broad sort of finding, or is it more specific to particular companies and particular setups?
Thanks for your questions. And in my research thesis, so we intend to use a quantitative method. We do the survey to our sample. We expect to have 200 survey from the general company, and from that we will analyze. We have some hypothesis and to analyze whether the entrepreneurship will be boost the resilience to effect to our DV is the performance. So we will analyze whether it's the risk taken, proactiveness, innovativeness will be effect to that.
And how do you measure entrepreneurship? What's your metric for it?
Entrepreneurship actually is the term, but the real term of the entrepreneurial orientation. It includes the 5 dimensions, but the 3 dimension is the most popular one. So I will mention is first of all, from my questionnaire. So from questionnaire, I saw some information that related to this dimension, and from that, I collect the data, and I will use the SPSS to analyze this, the data.
And so, is it qualitative or quantitative? I'm sorry, this is the last question. I don't want to hold
quantitative,
the limelight.
Please. Sorry,
here.
my pronunciation. Quantitative.
No, that's fine. So is it? Will you have numerical data, or will you have interviews?
We're just doing the survey. For the interview, we may think about that after we get the survey to see the result.
Great, thank you very much.
Thank you very much for your question.
I'm in this field currently
great.
because I work in business now, even though I was in science in the past. So one thing that, from my perspective, it is difficult to run a business or be in business without being entrepreneurial. So in my head, I'm going to throw you a bit of a curveball, which is, from my perspective, it is a little bit obvious that you have to be entrepreneurial to be successful in business. So I'm curious, what insights have you found so far that surprised you, or what do you think you can contribute to this field, which is going to be new and push it forward?
Yeah, thank you very much for your question. That's actually really to me, it's a very intelligent question, because I'm also thinking that when I read the literature, actually, because the literature is it's on the theory, but I was working before, and I don't feel like I compare between the literature and my own experience. But nowadays, when I'm looking at the current situation, so I'm thinking, okay, actually, it's more on the innovativeness, which means the innovative that we already, for example, we already have the project, but in order to upgrade it, or we do it different from what is available on the market, or even it will be compared to our direct competitors, so it can be a little bit more advanced or innovative products, so that can help us stand out the market, and so we can win the competitive advantage from that.
Okay, thank you. And if you need another person for your survey, I'm very happy to volunteer.
Thank you. Yeah.
For me, it's hard to ask any kind of smart questions in this topic, because obviously I'm not the expert in this field. So I would like only to say that, again, the great presentation, you use all your time, which we have to appreciate, because you had really perfect timing. And I really like that you refer to your slide, because for me as a person who is not an expert in the field, now after your presentation, I know a little bit more about conducting company and the research in this field. So thank you very much.
Thank
you. So thank you for a very interesting presentation. For me, it's very interesting your slide, because I am biologist, and MAR is for me very interesting, because in the marine of the organisms are very interesting. So how much money you need to accomplish your goal of your project?
Oh, so right question. Okay.
You are from the University of Economics, yes?
Yes, yeah, economics to work about the money. Oh, thank you. Yeah. Should I concentrate at the proposal? So sorry. Thanks very much for your surprise questions to me. But to be honest, I have never thought about that. Okay, I may know that during the research, when we deliver the questionnaire, or when we go for even the interview, we need to have some lump sum in order to support that. But to be honest, I haven't. I thought about that, but I haven't come really deep into that or have planned for that. So sorry.
This project is very rich.
Sorry?
This project is rich?
No, it's just I'm doing research by myself, so I can't say it.
Thank you.
Thank you very much. Thank you. Thank you.
And again, thank you very much. Yes, that's that moment. As you can see, when we have topic from outside our fields, there is plenty of interesting and not expected questions. So thank you very much one more time. And now we have the Polish representative in English, Patrycja Janiszewska from Medical University of Silesia, and we'll have the timer in a moment. So you will have 3 minutes, and the floor is yours.
Dear ladies and gentlemen, let's try something together. Please follow my lead. Please hands up, and hands down. Great. Let's do it again. Hands down, hands up, hands down. That was confusing, right? Imagine woman brain and body are musicians in an orchestra, usually perfectly synchronized. But in menopause, internal conductors' hormones change the rhythm. Musicians fall out of sync or stop playing altogether. It leads not only to hot flashes, sleep problems, or sexual difficulties, but also increased risk of serious diseases like heart condition, osteoporosis, and even obesity. But what if it doesn't have to be that way? Instead of treating women in menopause like a withered flower, no longer bright or beautiful, I want women to shine and bloom again. How do I do that? What if I tell you that the elixir of second life actually exists, and it could restore something that declines during menopause? Hormones. This elixir is called estrogen-based menopausal hormonal therapy. Some people say, it's too dangerous, it could cause cancer in women, but nothing is just black or white, right? This elixir, like all magic potions, must be used wisely, of course. In my research, I'm working to understand how this elixir really works, whom, when, and how it helps the most. To obtain a reliable statistical data, I conducted my research on representative group 500 women in menopausal stage from Silesia. As a tool, I use simple but thoughtful questionnaires, which contains questions about women's health, daily life, emotions, and sexuality. I collect and analyze data from these questionnaires to reveal a true picture of menopausal experience. The results? 100% satisfied women. Those women who use hormonal therapy not only feel better and have more energy, but they also have glowing skin, stronger hair, better sleep, brighter moods, weight loss, and better sex. They reported higher quality of life. And what about their partners? They get back the women they fell in love with. And that spark between them, it doesn't have to fade. Menopause doesn't mean the end of femininity or sexuality. Menopause, it's not a pause. It's a powerful transformation. Thank you so much.
Have the mic. Oh, now I have mic. You still have 15 minutes, so you could use it. I loved her gestures. Did you notice all the hearts and everything? It was so nice. Who first? Men in menopause. Please. Maybe Cuba now.
Happy to go first. Very nice presentation. Thank you so much for that. I really like how you confused us. I got tricked, and I like being tricked like that. Very well prepared. I lost the plot a little bit at one point, but maybe you can clear it up quickly. So the menopause itself, because at the very end I've heard that menopause is a good thing. So my understanding from what you're saying is that the menopause in itself maybe is not such a good thing, but if you're using something, there is something that you're using, is it some sort of pharmacological intervention which makes it better? Sure, okay, so that's the point I wanted to clarify. And now you used reports, right? So for example, when you were saying glowing skin, etc., this is all self-reported by the women in your sample rather than measured, right? So this is I'm getting to the methodology in here, which is self-reporting sometimes can be also misrepresented, right? So I'm curious if you have any other sort of proxies or methodologies that you're also using to check if the self-reporting is
no, only
is
questionnaires and standardized questionnaires like FSFE, female sexual function index, or Beck index on Cooperman index about menopausal symptoms, but this is I have questionnaires, so women write in these questionnaires what they see. So this is subjective, not objective.
And maybe one last question, which is, so what's the end goal of your research after you've completed it and you figured out that there is positive outcomes of using the specific medicine that you're using? What you're planning to do with it next?
As I said, I want to reveal a true picture of menopausal experience, so it could help healthcare's how treat these women, how help these women, maybe some healthcare programs to help and to improve them.
Okay, thank you.
It's finally a topic I can say something on.
Joanna was first.
Okay, thank you.
Yeah. You can say it to the mic because she's not hearing me, that she has voice. Joanna, you have voice. And now have
okay,
mic.
thank you.
Mic.
Sorry, I couldn't hear you. Okay, so thank you very much for that talk. And like Jakub, I also enjoyed being tricked. And yeah, I did love your charisma when you were speaking. And I was thinking, wow, this sounds like a really great product, and you seem to have fantastic results. And basically, 10 years from now, signing me up for this thing. But then I was wondering, what are the downsides? Because everything always has some flip side, some negative. Was there anything that is a downside in your study? Was there anything that was negative?
Not every woman can use hormonal therapy, so it should be doctor should individual talk with the woman and said she can use it or not. Yeah, genetic predispositions, for example, thromboembolism, yeah. It could be the black side of this treatment, but as I said, it should be, not every woman can, yeah.
So basically, not every woman can have it, but for those who can have it, they seem to be very satisfied.
Yes.
Okay, thank you.
Thank you.
That's good for us. Now you can speak, Professor.
But it was my question. Okay, so exactly, yeah. Again, so it's good that we now know the dark sides of hormonal replacement therapy. I don't think that we should go too deep into this topic. However, it means that I can say something positive. And my positive is my positive opinion is related. Okay, yeah, I really like the confusion at the beginning of your presentation, the energy of your presentation, your expression. So yeah, for me, the presentation was really, really great, and of course, the scientific part of your presentation was as good as your expression. Thank you very much.
Thank you.
Thank you. Thank you, Patricia, for the subject of this presentation. Your presentation was very optimistic for me. I am 50, and I think that menopause is for me as my friend. So I have one question. Do you know a plant species to mitigate of menopause? It is not rhododendron. No, this is rhododendron, but I ask you about the other plant, which are a help for women as me in the menopause time.
Oh, in English, I don't know how to say. In Polish, I can say.
You will translate.
Czerwona koniczyna.
Trifolium repens. Yeah.
Okay, guys, red cloth in English. It's helpful for menopause.
Thank you.
Thank you.
One more time, thank you very much.
Thank you.
Yeah, now we have the fourth person here, and it will be the representative of Silesian University of Technology. We have to prepare the timer and we have to prepare the slide. And Magda Ciertnicz-Wojciechowska, she is on the floor, and now it's her time. Just give us a second and let's go.
It's not working.
Sorry, it's not working because, okay, take your time. But you have a very nice slide. It should be blue and yellow, it will be very Polytechnica.
Yeah.
Breathe, please breathe. Okay, so tell us something about you, Magda.
Well,
What do you do? Where do you do this PhD?
Yeah, I'm doing the PhD at the Department of Environmental Biotechnology at the Silesian University of Technology.
Okay, and which year is this?
It's the 4th year, so I'm...
Almost finished.
Yes, I'm finishing up.
Looking forward to this. Are we ready with the timer? Thank you very much. Ready? Okay, breathe in, breathe out, and...
Long and cold nights, lack of the Basque cheesecake. This is how I imagine the times before the Industrial Revolution. And it's not really pleasant for me. What we would do without the fossil fuels. But hey, in a second, we will live without them. Our ever-increasing consumption led to depletion of the fossil fuels. Now we are in a situation when there is a real threat of returning to the times which I mentioned at the beginning of this speech. Can you imagine life without the cheesecake? Because I'm not ready for that. This is why I decided to do something about it, to have my contribution in replacing the usage of coal and crude oil, and at the same time to increase using of products from one process as a substrate in another. Well, I bet you heard about the sewage sludge produced during the wastewater treatment. I'm not going to bore you with the details, but they are considered as a viable feedstock for biofuel production, for example, during methane fermentation. This process offers a sustainable approach to waste management and energy generation. Unfortunately, using sewage sludge for methane production is not that simple. Their variable composition and hard-to-degrade organic compounds like cellulose limit the effectiveness of their processing. Did you know that one person uses around 50 rolls of toilet paper per year? That equates to 5 kilograms of pure cellulose in a sewage sludge, just from one person. So, considering other sources like plants, food and cosmetic industry, we get a huge amount of cellulose in the sewage sludge. Luckily, here I am. In my research, I'm testing the ability of microorganisms to improve degradation of cellulose and, in consequence, sewage sludge treatment. I drag out bacteria and fungi from the sludge where they exist and perform various processes. Then I check their cellulolytic abilities. When I confirm their positive impact, I put them back to the sewage sludge and check if returning those organisms into their original environment in a specified amount will improve the processing of the whole used biomass. I verify the concentration of volatile fatty acids, chemical oxygen demand, different nitrogen forms, of course cellulose concentration, and finally methane yield. Thanks to such treatment, I increase potential of the sewage sludge to be an alternative source of energy and decrease amount of not useful product from the wastewater treatment. And the cheesecake is safe. Thank you very much.
Thank you very much. Perfect timing. And who's the first now? Professor Edyta. Biologist, please.
How to say? Magdaleno, what scientific publication I should be read to get a grip on the state of art on this subject?
Well, I think that what is the problem with sewage sludge and the lack of energy, and how hard it is to transform cellulose, that this polymer is very hard to be degraded.
This type of the research realize do in all the world, but
yes.
It is an innovative innovation when you propose in
what
this
is
project.
innovative in my research is about the biological pretreatment, because most of the ways for sewage sludge pretreatment are chemical or mechanical, and the biological methods are maybe not so popular because they were not considered as that efficient as the other methods. But in my research, when I focus on the cellulose, I see the similar results as for very multiple methods from the chemical or mechanical pretreatment methods.
So, do you know one species of microbe, for example, which destroy of cellulose, for example?
Yes, I isolated two fungi which were able to degrade effectively the cellulose in the sewage sludge, and it was Aspergillus terreus, for example, and about the bacteria. They were rather working in a mixed culture. It was very hard to isolate the single microorganism which would be effective in a same way or similar or able to survive.
This subject is for you new?
Not really. I'm working on it for 4 years, so even more because I was attending the project during my master's studies, so not that new.
Okay, thank you.
Thank you.
Ready to go? So, Magdalena, thank you for taking me on a journey. Started with a cake, finished with a cake. So I have to say it was a pretty satisfactory journey throughout. I really like this method. We used it in sales, actually, in the past, which is always talk about something positive, and whatever you say is going to stay in somebody's mind. Whatever she was saying, even if I didn't understand, well, there was a cake in there, so I really liked it. It's a pretty clever method here. One thing that I kind of lost along the way was what is the research question that you are posing yourself specifically in currently?
Well, if I am able to find a very environmental friendly method for the improvement of sewage sludge treatment. Because those methods which are currently used, like those chemical or mechanical, have their disadvantages. For example, chemical is not that environmental friendly and also can cause a lot of damages for the equipment at the wastewater treatment plant. And the mechanical are also expensive, and the same may happen with the equipment.
That's a very good answer. I had a follow-up question, but you answered it already, so thanks a lot.
Thank you.
Yeah, so I will continue the previous question and the topic, because one thing for me it wasn't clear at the beginning, but now after the questions of the jury, it's a little bit more clear. But to be more specific, the goal of your research is to identify and isolate the microorganisms which can be possibly used for the processing of the cellulose, and possibly, for example, identify the enzymes responsible for that to make them more efficient, or to design technological processes which uses such a microorganism. Because, you know, one thing is purely research, and the second thing is related, you know, to the practical application of your research.
Well, the plan is to, for the application, to construct such a biovaccine that can be used in a specified amount, depending on what is in the biovaccine, and applied at in the industry.
Okay, thank you.
May I have the mic? Thank you. Joanna? Any comments?
Well, so Professor Francis has reciprocated because he asked my question this time. So thank you. No, I won't take your time. I really enjoyed the presentation. I'm more interested in the toilet paper and how much of it we produce than in the cheesecake. But because we got both, I'm still satisfied with the talk. Thank you.
Thank you very much.
Oh, Kuba was disappointed that you are more interested not in cheesecake. Please. He has different priorities. Thank you very much one more time, Magda. Thank you very much for the questions. And now we have the next Salesian University of Technology PhD student, Ravi Shankar Yadav.
Every day we face some challenges to clean our wastewater, recycle our some waste, also restrain the soil contamination, and do some carbon sinking, like for the greenhouse gas reduction. And just imagine there is one guy came and they told, okay, I will help you to take care of all of this. It is amazing, right? So that guy is biochar, and hi everyone, my name is Ravi Shankar Yadav, and today we will talk about that guy, that is biochar. We also call it black gold. It is too much popular in wastewater and waste recycling environment. So what is biochar first of all? So biochar is a carbon-based material that can produce by the agricultural waste. We burn it in absence of oxygen, and for the application we do some engineering and we make fine particles, and in that condition the efficiency of that biochar increase, but at the same time it also increase the ecotoxic concern to the environment. So my PhD is based on that. We going to evaluate how much the concern of our environments is due to the engineered biochars. So that side, the main target of the first of all, we will talk about the positive side, that is target side. So we will have a biochar that can clean water, that can do heavy metals reduction, bioremediations, also so many pollutants. They can also do the treatment. Also, he has a capacity to do a carbon sink that it can reduce greenhouse gases. So there are lots of other applications also. But at the same time, we forgot to see they have other non-target effects as well. That is ecotoxicity. And my part is to evaluate the ecotoxicity. What is ecotoxicity against the bio indicators? So what is bioindicators are? Bioindicators are tiny creatures which we can find throughout the environment. It can be vertebrate, invertebrate, some aquatic, non-aquatic animals. So we will see there. So this is our question. So is that a special superhero biochar have also some dark phase? So that thing we are going to reveal in our PhD. And what we found till now, so the consumption of biochar is not bad to we can consume it carefully with awareness, with some guidelines. So that is all. Thank you so much.
That is all. Thank you very much. So now we have these two faces, the good and the bad face of biochar. So thank you very much for your speech. Who first, Jonna, or maybe?
Yeah, I can start. Why
No
not?
one
Nobody
will
pitch
take
my
your
questions
question.
now. Good. So I feel like you started talking, you got me really interested, and then you got to the best part, and you finished. Because I need to ask you, like, which organisms do you use? What are your bioindicators? Because you said a whole host of organisms. Yeah, I mean, there's a lot of organisms out there. Do you have any specific ones? Do you study them in the lab, or do you study them in the field or in more natural settings? I want to know more about this, basically.
Actually, first of all, I'm very early stage of this research.
Okay.
So right now I'm working on a Daphnia, also a Vibrio fishery. Also we use some aquatic Daphnia, and we also try some plant that can also have some bioremediation property. So we are using this kind of bioindicators right now, and we have planned to make it in a pilot scale in the real agricultural field. So it would be the next part.
Excellent. Thank you very much.
Okay, so my question is really simple. It's not my topic again, but please tell me, let's assume that you, as a result of your study, you will find that biochar effects on the environment are highly negative. So what next?
Actually, it is since now they have several study has been gone, and it shows like in the normal use it is not that much harmful. But when we do the engineering part, we merge some other heavy metals to it to have some another applications. We also make nano biochar to make it more finer, so they have a high surface area, and it can give more applications. But in this engineering part, we forgot that they have other non-target effects also. So that would be our concern, and I think we can make some guidelines. So this much concentration can be used, or higher concentration it is better to avoid.
Thank you.
I really like how you started, because you've done a really neat trick, which is you introduced a piece of jargon, which is biochar, and you immediately turned it into a person and treated it as a name. So it actually stuck with me throughout. It's first time I see that. That's very well done. What I was curious about, though, and I could kind of feel that you run out of time a little bit when you're getting to the most interesting part. What I wanted to ask about is the overall impact of that. How much do we actually use biochar right now? Is it in use, and we're potentially polluting ourselves with it? Is it something that we are only considering to start using?
Actually, in agricultural field, we use a lot because they have many places and so many research has been done. This shows the better part, they have some like wastewater treatment plant. They use biochar very often because biochar have a high surface area of carbon, so that can it is easy to bind the pollutants to the biochar. So it is high, lots of place and lots of industry also using biochar, and that is our question. So we are gonna use it more and more. So maybe, and we don't know what the consequences will be in the future. So we are concerned about the future because those tiny allies are important of our food chain, aquatic food chain, sometimes in non-aquatic food chain as well.
Fantastic, perfect answer. Thanks a lot.
Thank you.
My question is short. What did the idea for project come from?
Actually, we were working on ecotoxicity. So right now we are working on biochar is nowadays a very emerging technology or green materials that we can say. We have also planned to work on different nanoparticles like TiO2 nanoparticles that is normally used for sunscreen, and everywhere we are using sunscreen. We don't know after washing off what the sunscreen nanoparticles will do to the environment. So this is one of the part. We can increase that part later again, And this is actually how we think like that.
She was waiting that you will say it was my promoter who invented the topic.
Okay. Oh, I'm sorry. Of course it is my promoter. Of course it is my promoter's idea.
I like biochar and problem with biochar in environmental, because biochar is a very is a problem for the I don't know how to say. So I wish you a big success with biochar in water.
Thank you so much, Professor.
And identify ecotoxicity. So this is a typical test of ecotoxicity. Right. Toxicity, yes?
Right, right.
Not new aspects in the assessment of ecotoxicity in the water environment in this PhD innovation.
Yeah, the innovation will be we are gonna do work on different engineered biochar, because indicators would be the same. We can't change the indicators. What we can change the parameter of our subject. So we will check in a different environmental stress, different pH, different temperature, real-time temperature, real-time environment. That we can change. We can also change the size of nanoparticles or biochar in different size, how it impact, and which concentration can be usable and friendly to the environment. That we can do.
Thank you.
Thank you very much.
Thank you so much.
That's all. Thank you very much. One more time, thank you very much for your presentation, and thank you for the questions. As I noticed that in case of Cuba, it's really easy to draw your attention. Cheesecake or someone who has name, it's not a problem actually. Yeah, I can imagine. That was very human being presentation. Thank you very much for the 5th presentation, and now we have the 6th presentation, and it will be Cosmos Uzłoma from Salesian University of Technology. Welcome him very warmly, and the floor is yours.
From the late 1940s up to this time, we have witnessed an incredible transformation in the size of computers, shrinking from room-sized machines, like the first generational set of computers, to portable and powerful devices that we can now move around with. This evolution in size reduction has been made possible through research, unlocking new materials like silicon that made it possible to shrink the size of the major components of our devices without compromising their performance. However, silicon, which has been used for decades to fabricate our electronic component of our devices, is approaching its physical limit, which means any attempt to reduce the size of silicon-based devices will compromise the efficiency and the performance of our devices. Hence, for the sake of prosperity, we are seeking for an alternative to replace silicon in the future. Among the list of potential materials is carbon nanotubes. Carbon nanotubes is 10,000 times smaller than a human hair, with exceptional electronic properties beyond silicon, which means replacing silicon with carbon nanotube will not only make our devices smaller, but increase the performance compared to what we have today. However, there's the challenge. Carbon nanotubes, when produced, are produced as a mixture of different types of carbon nanotubes. Some behave like metals, some behave like the semiconductors, which is often preferred for developing our devices. Hence, to unleash the potential, we have to separate the pure semiconductor carbon nanotubes. However, this is very difficult, and all known technique requires sophisticated and expensive equipment, which means large scale will be very difficult because it is expensive to carry on with. This is the area my research is currently working to address. I'm working on a simple two-step technique with low-cost method that will initiate separation of carbon nanotubes using polymers. This step is called conjugated polymer extraction because it uses polymer to form two phases where we can find our desired choice of nanotubes at the top phase, which we can further obtain using our membrane. This is a simple step that requires no technical and difficult techniques. Thank you.
Thank you very much. I can see that this beep in the end is very stressful for you guys. This is the second person. Thank you very much for your great presentation. And I would like to hear some questions from jury. Who's first? Should I pick one? Oh.
Okay, so thank you for your presentation. And unfortunately, there wasn't enough time for you to present everything, I suppose. And possibly the most interesting part is still missing, but doesn't matter. Please tell me, because I really wish to understand, you mentioned about application of carbon nanotubes as a possible semiconductors.
Yes.
To replace the silicon.
Yes.
But silicon is used in the chips, which consist of millions of transistors, billions of transistors now. So how isolation of a single nanotubes will let you to combine them to more complex structures, which will resemble the silicon structures we use now?
Okay, so like I said, nanotubes are smaller, and because of that, we can be able to have more or twice the number of transistors that we have today in our microchips. So that will increase the performance of our devices compared to silicon. And the fact that this material, in theory, is twice the electronic performance of silicon. So we expect that this will do better, not only by the performance, but we'll have more transistors in our chips.
Yeah, okay, I can understand the physical properties of the carbon nanotubes, but the problem is that, please explain it if I'm thinking wrong about it, but let's say the carbon nanotube, single carbon nanotube will be, let's say, equivalent of a single transistor. But the chips contains billions of transistors. So how to combine these single nanotubes to produce such a complex structures? Because we have a nice technology, for example, for silicon chip, like chemical etching and so on, and it works perfectly fine. But how to do such complicated processes on the nanotubes?
I'm not sure I get your question exactly. Could you rephrase?
Okay, so I will try to make this as simple as I can possibly. One single carbon nanotube is an equivalent to how many of transistors?
Okay, yeah, I think I get your question now. So now this is the best part. The best part is that my process will not just isolate nanotubes, but we increase the yield of nanotubes that we have, so we can have more quantity, to do this fabrication to develop our transistors.
Oh, okay, thank you.
I think my understanding is that generally I would say start from that. The problem you're tackling is an absolutely crucial one. That's for sure. I mean, it's a multi-billion-dollar question right now, how to do separation of assorted nanotubes correctly. If you manage to do it, that's a huge step forward. Now, the question that I have, what I'm trying to understand is, which part of that research is the part that you do? Have you invented the method itself, or are you working on, for example, an obstacle that stops us from succeeding in actually executing on the method which already exists?
Okay, currently we are working on developing the main material, which I said is polymer, conjugated polymer. So right now we are on the stage of synthesizing this polymer. It has to be specific to be able to separate our choice of nanotubes. So now we are doing this synthesis in-house by ourselves, and then when we are done with that, we proceed to the next step, which is separation. Yeah, but this is like the schematic representation.
Okay, so you're coming up with how to manufacture this polymer. Are you at the stage of how to manufacture that polymer in the lab, or are you already thinking of how to manufacture it in larger quantities for industrial uses?
We are already doing it in the lab.
Mm-hmm.
We are already synthesizing it in the lab.
Mm-hmm.
We are working on it, but it is complex as it looks.
Mm-hmm.
So we have to get the right properties of the polymers to initiate this separation.
Mm-hmm.
Properties like the molecular weight, the dispersity index, and the chain length. So this is very crucial. So it takes time. It's not as easy as it looks in the slide.
Absolutely. And last question, what is your part specifically? Which part of this process do you work on?
Okay, I'm working on the separation part, and currently through the guidance of my professor, we're trying to collaborate with a school in Germany that is going to do this fabrication. So my work is to make sure that I develop perfect polymers that we initiate this separation, then we can send our samples to Germany for it's more like a collaboration.
Fantastic. Thank you so much. And by the way, super jealous of your name. I would love for my parents to call me Cosmos. They missed the trick there.
Thank you very much. Your presentation for me is very difficult. Yeah. I have a short question. Tiny tubes are big future for the electronics device, but what about the environment?
Environment?
Yeah.
If it has any...
Tiny tubes in environment and impact on the environment element, for example.
Well, I've not really dived into that, but I guess I'm so focused on the incredible properties of these materials that I can actually, change the future of electronics. Because like I said, something has to be done with regards to silicon reaching its physical limit. So I guess this I will not really focus on the environment part of the whole issue now, yeah.
Thank you.
Thank you. Joanna, any comments?
This time Professor Sherka has snatched my question. So I just wanted to say that I really enjoyed your delivery style. It's so calm and very well-paced. So thank you for that.
Thank you very much.
Thank you very much one more time for your presentation and for all the questions and comments. Thank you very much. And now we'll have the next person. Now we'll have the Medical University of Silesia in Katowice, and it will be Jakub Pniak, who is somewhere here, and the floor is yours.
Good evening, ladies and gentlemen. Let me start asking you two simple questions. How many of you have ever heard about Viagra, the famous blue pill? Please raise your hand. And don't be so shy, really.
Only heard.
Yes, exactly. I think the most of you. Thank you very much. And the second one, how many of you have ever wondered about the development of a new drug, for example, anti-cancer drug? Okay, thank you. And now, in a little bit less than 3 minutes, I'm going to show you that my PhD thesis links both these topics. First things first, the development of a new drug, new innovative drug from scratch is a long and very costly process. Currently, it takes an average of 12 years and can cost from $300 million to even $4.5 billion. Of course, it's possible to shorten the required time and significantly reduce costs. The method is called drug repurposing. Sounds scary? Difficult? Don't worry. In fact, it's simple. Repurposing is nothing more than use of already known pharmaceutical substances, ready on the market drugs, but for new therapeutic indications. In my doctoral dissertation, I assessed the potential for repurposing selected drugs in the context of anti-cancer properties using cell lines. Specifically, I'm evaluating two pharmaceutical compounds, sildenafil, which is exactly the same as in the famous blue pill, which I asked you about, and tadalafil. Both are widely known for their primary use in treating erectile dysfunction. Now, some of you may be really surprised because linking impotence medications with cancer, it sounds unusual, strange. I think it may even bring a smile to your face. Nevertheless, it still can be the proper approach because according to the latest research, these substances interact with multiple targets in the body, not only one located in tissues and penis. Of course, I could explain it in a more scientific way, but don't worry, I will not delve deeper into the biochemistry or molecular mechanism of action because we simply do not have time to do that. Now, a little bit more seriously. The most important thing in my speech, which I would like to emphasize, is that breast cancer is one of the most common type of cancer in women, and a leading cause of death cancer among women. That's why we should try to find new solutions and new treatments. So to recap, we started from pleasure, but finally we can get a new weapon to fight against cancer. Thank you very much for your attention.
Thank you very much. Thank you very much for this serious presentation. In the very beginning it was haha, and then Okay, so who is starting? Maybe Joanna? Any questions?
I can totally imagine newspaper, very sloppy headlines going, "Can Viagra treat breast cancer?" after hearing this. But I wonder, because you mentioned according to the newest research, could you go a little bit more into your contribution and what it is that you are doing as part of this project?
Yes, of course. Generally, idea with using tadalafil is mine because I have read that sildenafil, and generally we know that sildenafil is it has a potential of anti-cancer. Of course, depends on what type of cancer, and usually it's a combination of more than one factor. So not only sildenafil, but with combination with other therapy. Nevertheless, using tadalafil is something new, a little bit more interesting as well, because tadalafil is similar, but it's also different. It has a different structure, different chemical structure, and different dosage. For example, it's possible to use it once a day, not, for example, 3 times a day as sildenafil. So, it's generally, I wanted to avoid too many details and going too deeply into the mechanism of action, the differences, similarities, because, the time is a limitation, and I didn't want to make this presentation too boring, because the border sometimes is very tiny.
Great, thank you very much.
Thank you.
So I had some questions about methodology, because so obviously the first thing that came to me was, are you basically purchasing large quantities of Viagra and then doing experimental studies on it? What's the research question that you pose yourself? Because I can see that this is about repurposing. My guess is you're not experimenting on people currently. It's more of is it a theoretical study? Is it an industrial study? What's the actual methodology and the research question that you pose yourself?
Okay, thank you very much for your question. As I mentioned in my presentation, I use cell lines to be more precise. Two types of cell lines involving breast cancers. Of course, I could give you the name of these cell lines, but I think it's too boring for the audience. I'm not generally. It's a stage of laboratory research, so not preclinical ones, not clinical studies, not clinical studies, but laboratory research. So it's the first step.
So basically, my understanding, it is a lab study. What is the sort of the research question that you pose yourself? What is the challenge that you try to address yourself here? I fully understand that you're saying that this was a little bit complex, so it's better to stay on the light side of things, but maybe go a little bit deeper so you have some appreciation of what you're doing.
Well, currently I'm in my first year, so I didn't complete all studies which I planned. But the main question is, do sildenafil and tadalafil really work on this, really affect this cell line, two types of cell lines? And I assess, for example, apoptosis, angiogenesis, cell viability, proliferation, and something more aspects, but involved in this area.
Okay, thank you.
Thank you very much. I'm a little bit scared now.
Okay, I will try to do my best. Please forgive me if my question will be too much scientific. The audience, please forgive me. But I'm really interested because obviously we have a large group of tadalafil and sildenafil users all over the world. And what do you know? What do you think? What do you know about this? Do you know any kind of clinical trials in which the result clearly shows that there are some benefits in terms of cancer occurrence reduction in this population, or should we use, for example, such drugs and their possible side effects for the prevention of the cancers?
Well, I have read about clinical trials and some publications as well, which were involved in colon cancers generally and prostate cancer as well. So in this type of cancers, the results, especially in prevention, which you have mentioned, were generally positive. But it's a little bit more complicated because it depends on type of cancer, on combination factors. Is it single therapy, monotherapy, or a combination of more factors, more ingredients?
Okay, so it's quite interesting because, for example, the users of these compounds can expect, as additional benefits, the reduction of probability of, as you mentioned, the colorectal cancer. Yes.
Yes, exactly.
Okay. Yeah, it seems so.
Okay. but really, it's a scientific fact because according not one but many research, many trials, it's a positive benefit when especially older men use these drugs.
Good. What results you expect from your research?
Well, I try to be objective and to not focus on result on this stage because, as I mentioned, I'm in my first year. But after some, let's say, beginning stage, the results are optimistic because I have achieved some positive results, for example, on apoptosis of these cell lines and cell proliferation. So the first results are positive. But I'm not going to the details because I haven't published.
Go to the details, please go to the details. You're just saying that everything is so difficult. Please, you gave us Viagra in the very beginning and now you're not giving anything extra. Please do it.
Okay, so as I have mentioned. So as I have mentioned.
Just open yourself with this topic. You have it inside.
I thank you for your answer.
Really positive.
I can see that you're very positive, but you're very shy in sharing details of your research.
It's really excited about this topic.
I like Viagra. Everyone who uses it likes Viagra.
But as we discussed,
it will be for women as well. So I understood that it will be helpful for me. So I'm very happy that someone finally noticed that it could be useful, not only indirectly.
Yes, as we discussed, it may be positive, or even it is a fact that it is positive for older men, but we have to check it.
What do you mean by older men?
Let's say above, above 50.
The limit of age now is very flexible. Like 50 is, it used to be like new 20 or 30.
Yes, of course.
What is the definition of older men?
I think this question is very tricky, so I would like to avoid.
Thank you for your answer.
But tell me, because for me it's very difficult to assume in which time it's the older men. Like,
Well,
see?
I think there is a type of correlation between, for example, rectum cancer and age, and probably it is most frequent in people above 50 or 60. Of course, it depends. So.
I don't like it.
Stop.
Oh, I'm just joking. Thank you very much. Any other questions? If not, thank you very much.
Thank you once again.
Next presentation without any Viagra. Why we don't have the mic here? It's working or not working? Someone switched it off because I'm talking too much. That's why. And now we have the 8th PhD candidate, Kamil Mąkosza from Medical University of Silesia in Katowice. And it's your 3 minutes.
My name's Kamil Mąkosza, and I am dietitian. Today, I want to talk about silent killer hiding in plain sight. Can you imagine up 85% of cancer patients die from consequences of disease and its aggressive treatments? Malnutrition, not just tumor, is silent killer. Isn't that terrifying? Every day, patients hear, you have cancer. You have cancer. It's just beginning of galactic journey into unknown. Many of them don't die because treatment failed, but because side effects of therapy, like chemotherapy, surgery, or radiotherapy. 4 out of 5 patients are at risk of malnutrition, and nearly 1 in 3 won't survive. Not because treatment was failed, but because side effects of therapy are unbearable. These therapies save lives, but also damage healthy cells, cause fatigue, fear, malnutrition, forcing patients to stop therapy. My research goes beyond numbers. I personally talk to patients, listen to their stories, and try to help. I have 3 aims to support patients through this difficult journey using interviews and clinical tools. First, nutritional status. I identify signs like pain, weight loss, and taste changes. This helps me tailor nutritional strategies to maintain strength. Second, quality of life. I study how disease affects daily lives, aiming to implement interventions that improve their well-being. And third, secondary prevention. I combine medical data such as tumor location, stage, and lab results with daily habits like diet, activity, and medication adherence. What's innovative? While medical diagnoses follow standards, patients' needs and experience do not. And that's why I personalize nutrition care in cancer. My research are really needed. Why? Because I combine medical data with individual conditions. With individual conditions. And I aim to develop new correlations and tailored nutritional treatments. This work requires time, trust, and emotional resilience, because without proper nutrition, there is no effective treatment. Thank you so much.
Oh, it was a very passionate presentation. Thank you very much. And who's first? Oh. Cosmos.
Yeah, well, there's a galaxy in the name, so obviously I had to start. So you mentioned you personalize the approach, and I fully agree, right? I mean, if the cancer attacks somebody, well, they obviously first they have to concentrate on the treatment, but we're all different, we all have different tastes, and catering to these tastes seems to be, at least from my perspective, an important thing. You said that you personalize the approach. How do you personalize it? Because my understanding is that you do empirically based medicine, right? So then there has to be a common approach that you have to all the patients, but then you also add some sort of personal flavor. Can you explain a little bit more about that?
Okay, thank you very much for this question. My research are connected with gastrointestinal cancer patients. The study group is patients who are diagnosed gastrointestinal cancer, for example, stomach, liver, pancreas, or some internal organ, and the patients are in various age, but only adult persons. I included various factors. I want to develop, I want to know how these factors are connected, because my research are comprehensive. I am oncology dietitian, and I'm focused on dietotherapy. This aspect is really wide, and it's really not simple, because other patients with this same group of cancers may have other symptoms, other problems, and the therapy should be really individual. These processes are really difficult, and I think that my research are really needed, because in clinical practice it is unfortunately really unsatisfactory. Research in these topics also are rarely meet. And sorry, I'm not certain that I understand your question, because
if you can just tell me, because I fully agree that there is standard treatment that can be given to the patients. There's also the personalities of these patients. There's their preferences. There's the ages potentially. My wife is an oncology psychotherapist, and she every day would come back home saying how much she had to personalize what she does with the oncology clients, oncology patients. So my question to you would be, what is it that you specifically personalize? What is it that you do differently, basically, for other different patients? And the second part would be, the question would be, what is the research that you actually do? What's the methodology? What's the research that you actually do yourself?
Thank you. As I said, I'm concentrated on three aspects: nutritional status, quality of life, and secondary prevention. To conduct my research, I use interviews, surveys, and clinical tools. For example, it is mini nutritional assessment in full version to show how each patient story is it in real world. This work takes a lot of time, and is really complicated. I have a lot of questionnaires, and for example, statistical analysis included a lot of various factors. For example, external and internal, and the analysis is really hard, but it gives me a lot of satisfaction, and I want to develop something new. That's all.
Okay, thanks a lot.
Your galaxy is nice. This is a AI project. You prepared this by the AI, but it's your artist picture.
And AI was a little bit help for me, but the final version is my in Canva program. This slide shows galactic journey, and all these factors are really connected with the patients.
I have a question. What is most important for me in the aspect of the cancer care?
The most important
in
my
opinion,
opinion,
yes.
the most important thing of care is nutrition, is food, because I'm an oncology dietitian and I know how food in chemotherapy, surgery or radiotherapy has a really crucial role in patients. They have a lot of different and various problems, comorbidities, other diseases, and the common recommendations to this group of patients is impossible. So the individualization.
So I ask about for me.
Okay.
Not an oncologist by patient. Ask the person who doesn't have cancer. What is the most important part?
The most important part is healthy lifestyle and diet.
So eat well and move a little bit. You can just run around the and then you can eat sandwich.
Okay. And then let's. Okay. Thank you.
Professor Francis, any questions?
I'm just wondering, because you mentioned how important the correct nutrition for the cancer patients is. So what do you expect? Is there any measure, or how you can measure, for example, the effectiveness of your research? So let's assume that you will be able to provide a new protocols for the nutrition of such a patients. So what do you think? How much the outcomes of cancer patients will improve?
Okay, thank you for this question. I observed that a lot of patients at risk of malnutrition or malnutrition, so the nutritional interventions are really needed, because when patient has a risk of malnutrition, there is no effective therapy, so chemotherapy, radiotherapy or surgery. In my opinion, there is no sense where the organism isn't nourished adequately, and I think that outcomes, the final outcomes, are really dangerous, because in hospitals this problem is really frequent, because it's only one dietitian employed in all hospital. It's a terrible fact, because this group of patients should individual care of dietitians. Every day should be process assessment of nutrition in depth, not only short, but in depth to observe fully situation, fully comorbidities, symptoms. Besides the somatic, also important thing is mental health, and this aspect is also in my PhD research, because these issues are really connected.
Thank you very much.
Thank you.
And
Any
I've got
comments?
a quick question. So you mentioned that your research is on patients with gastrointestinal cancers. Do you think there is potential for this sort of approach for other cancer patients as well? Is this something that you're considering in the future?
Thank you for the questions. Some outcomes may be common, yes, of course, because some recommendations for specific symptoms may be similar, but not all. This group of patients is really danger of malnutrition, because there are gastrointestinal cancer, and as I said, almost 90% of patients with my study group is at risk of malnutrition. So this is, in my opinion, really important research.
So is it easier to treat a patient with other than gastrointestinal cancers with diet? It would be easier.
No, it is.
It's different.
It is
okay.
really different.
Not easier, but different.
It's difficult
okay.
because a lot of comorbidity symptoms when patient cannot eat by mouth. Then there is internal or parenteral nutrition, and these issues are really different, are really other. I said my research I conduct are connected with patients who can eat from oral cavity from mouth.
Okay.
Thank you.
Thank you very much. Thank you very much one more time for the presentation, jury, for the questions. And the last but not least, again, she was during the elimination, she was the last one, but not the least one. And now again, Humam Ahmed from Salesian University of Technology. Finally, it's your turn. Fingers crossed. The floor is yours.
Hello everyone, I am Humam and I have a very simple question for you. What's in your water? Now probably you are thinking, oh, water, maybe some minerals or chlorine. But what if I told you in some places your water might contain some antibiotic, painkiller, or even a hormone floating on it? Congratulations, you are taking a sip from the world's tiniest pharmacy. Now don't panic, I am exaggerating a bit. But yes, scientists have found traces of medication into our rivers, lakes, or into our tap water. Now the question is, how does it enter our water environment? Let's say you have a fever, you took a medicine, your body absorbs what it needs and releases the excess amount of dose from your body in a natural way. Also, in some places, people flush down expired pill down the toilet. And the problem is that these pharmaceuticals doesn't get disappear. They are tiny, sneaky, and persistent. Fish get confused, bacteria gets stronger, and we human, well, we are drinking a cocktail that we never order. So what we do? Here comes advanced oxidation processes. Consider them as a water personal superhero squad. Consists of powerful weapons like ozone and hydrogen peroxide, creating something called free radical. And those free radicals are highly superreactive molecules used to convert harmful substance into the harmless bits. In my research, I tested which advanced oxidation process works best under what conditions and how long does it take to zap those contaminants. Basically, in my research, I run a mini spa day for water, exposing the water to the right amount of the UV light, chemicals, and time until it comes out clean and safe. Now the question is, why does it even matter? Well, cleaning the water is not about removing a dirt. It's about what we can't see is not hurting us. My research helps design future treatment plans to deal with those stubborn invisible threats. So next time when you drink a water, remember, science is working behind the scene to make sure water is pure. And with advanced oxidation process, we are not only cleaning the water, but also protecting the ecosystem and public health to make sure what we drink is clean, pure, science-approved, and pharmaceutical-free. Thank you.
Thank you very much. Oh, you still have 12 seconds. Yeah. And who's first with questions?
I'll go. Why not?
Okay.
Thank you very much for this presentation. I found it really inspiring, actually. I was wondering, in your research, do you just look at the water and its properties, or do you then take that purified water and actually present it to different organisms? And if so, what are these organisms?
No, basically I work with 3 different water matrices. First of all, molecule water because of its ultra pure property. And then I take a tap water to check the behavior of drugs into the tap water. And then I use the real environmental matrices from the river, which I collected from Ostripka. I don't know the pronunciation. Yeah, so I tested the behavior of drugs into these 3 environmental water matrices.
Okay, and so do you measure the impact then on different organisms, or just the properties of water?
No, no. I am only doing the abiotic, analyze the degradation effects, but only for abiotic factors.
Okay, thank you.
Yeah.
Thanks.
Okay, so my question will be strictly chemical question. What are the advanced oxidation end products of these organic molecules? Because I assume that, is it a simple molecules, like for example, carbon dioxide, or some more complex and possibly harmful? Because for example, the very similar process takes place in human body, and sometimes, for example, oxidation by different oxidases produce highly harmful products. So for example, in case of paracetamol, acetaminophen, the drug which is used as painkiller, for example, the actual product of oxidation of this drug is toxic for humans, not the drug itself. So maybe by introducing such an advanced oxidation products, you do more harmful that.
No, it is not harmful, because let me clear one thing. Advanced oxidation process is a set of the chemical reaction which is used to remove the targeted pollutant. In my case, targeted pollutant is anti-COVID drugs. So and I expose it to the UV light and then check their degradation behavior under the UV HPLC methods. And by using the photocatalysts like titanium dioxide, zinc oxide, and different. Basically, I work with 7 different photocatalysts to assess the behavior of these drugs in 3 different environmental matrices.
Okay, thank you.
So maybe I'll follow up in the same vein. So when I was listening to you, first of all, good flow, good context. I understood what this is for. One thing that I kept having in my mind was, I think, a similar question, which was, so if you have something harmful in water, then you use advanced oxidation to break it down. The first thing that comes to my mind is like, and the things that you broke it down into, are they safe for us? And yeah, so it was basically sort of a similar question. So maybe if you can say a little bit more about that, because maybe it is still harmful to us. Yeah. And you also mentioned free radicals, which also sort of in my brain sounds like something that could potentially be.
Free radicals are superreactive molecules like hydroxyl radicals, which are released when we expose the photocatalyst to the UV light, and they are very strongly oxidative, harmful, and superreactive molecules. First, they break down the organic contaminant into their fragments, and in last stage, when exposed to the UV light, they mineralize the pollutant into carbon dioxide and water, which is not harmful.
That's okay for us, that's true. Unless too much of it. There's always too much of a good thing. And then the another question that I had was, what is it that specifically you do? What is your part of that research? What do you do? What's the methodology? And the sort of the research question that you pose yourself?
Okay. I basically assess the behavior of anti-COVID drugs in water environments, and I analyze how different water matrices affect the removal efficiency of these drugs and also which is the best photocatalyst, or you can say best substance which release the hydroxyl radical to eliminate these pharmaceutical from the water environment.
And what's sort of your hypothesis that you try to prove or disprove, or was this sort of the research question that you posed?
The hypothesis was at present there is no research reported on the abiotic factor related to the abiotic factor in order to remove this pharmaceutical, and I work on the catalyst dose. I will check the pH of the solution and the amount of irradiance and this thing. These all the abiotic factor, not the biotic one like enzyme and other things.
Okay, thank you.
Do you conduct research in the laboratory on the environment, in situ or ex situ?
I conduct in the laboratory, but we
only.
have... Yeah?
Only.
Yes, but we have a solar box which is which emits the radiation to the equal to the 52 parallel north of the pole and sunlight. So it's a good, and I work on 500 irradiance, so watt per meter. So it's
basically align with the average sunlight which is present during the summertime in Poland.
So this water, which we will be researched, it's from the, you prepare this substance, yes, in the laboratory with
water?
this, with water and the medical.
Yes.
Yes, you prepare.
Yes, I make a working standard by using the test compound that obtained from the pharmaceutical companies.
Okay, thank you.
Yeah, but she has 3 different waters.
Yeah. Yes, yes, yes.
Any other questions? No? Thank you very much. One more time. Thank you very much, Mom. And guys, this is the end of the final presentations. A few technical hints. First of all, you have a card on which you should write down which person is your favorite for the publicity award. And David, come here, David, please. This is David, and he will collect all the votes. So please write down and give him them back. And now we have a 30 minutes break. I hope it will be a bit faster, but 30 minutes, up to 30 minutes, we'll know who is the winner. Thank you very much. Jury, you will follow Beata. Where is she? And guys, there is coffee, water, and something to eat over there, so enjoy yourself. Dobrze, słuchajcie, idziecie Have the verdict, so come back here, please. Professor Werle is asked to be here ASAP. Oh, here you are, ASAP. Tak, oczywiście. Potrzebuję protokół i dyplomy.
Jakkolwiek będziemy to liczyć, 9 osób, 4 nagrody, rozumiem?
Mamy? To bardzo proszę.
Przynajmniej uścisk dłoni.
Nie mam tutaj dyplomu dla AMT Systems. Dyplom dla AMT Systems potrzebuję. Ale ja potrzebuję tu ten. To, tak? Nie. No muszę mieć dyplom dla niej przecież. Kto ma dyplom dla niej wypisany?
Nagroda inżynierska?
No. No nie ma. Jest pierwszy, drugi, trzeci. Tu jest publiczności. To jest na końcu.
Aha, bo chyba nie ma dyplomu, oni dostają tylko ten voucher.
Tak? Nie ma na pewno dyplomu?
Nie.
Dobrze, okej, dobra,
Tylko
okej.
certyfikaty, nie? Ale to nie ma... Aha, okej.
Invite Vice Rector of Salesian University of Technology, Professor Sebastian Werle, to join me here. First of all, I would like to thank all of you guys. You were absolutely amazing, and I think that we all think that. So please, thank to our finalists. Do we have Joanna? Do we have Joanna on Zoom? Because now I don't see you. Jest Ola tutaj? Oh, thank you. Hi. Jury, please tell us, was it difficult?
Very much, yes. So difficult, yeah.
Okay. So, dear rector, you need to give all, to present. We have the first one. This is the award from European Journal of Pharmacology, and we have actually two guys here.
Okay.
First.
Okay, so first award from the European Journal of Pharmacology goes to Magboech Karosi.
Yeah.
Sorry for my pronunciation.
Okay, dobrze. Masz dyplom? I dziewczyny dają.
Yeah, congratulations.
Yeah.
Good job.
It will be the financial award, so now you have only the diploma, and the rest you will get, and the second one, also the same.
Okay, and the second goes to Mr. Jakub Pniak. So boring.
Yes, so boring. So boring. So boring. Jakub is the second person awarded. Show yourself. Don't be boring. Show yourself.
Okay, so now third place.
Oh, wait a minute. Agata.
Agata.
And the voucher. Come here. And the voucher. Because I don't know who is the winner here. We have the engineering award. And who is the engineering person here? You didn't write it down here.
So
we don't have a diploma for this, so you have to write it. You have to tell us what was it.
So it's not mine.
Magdalena Ćwiertniewicz-Wojciechowska.
Dobrze, to wręczcie. Tutaj jest voucher, a tutaj jest...
Może pomogę jakoś czymś.
Proszę bardzo. Że się... Madziu, ten voucher musisz tak przodkiem. Pani Agato, proszę się ustawić ładnie do zdjęcia z panem rektorem i voucherem. Great, thank you very much.
Pasowałem do pani, ale to nic.
Third place.
Okay, now
You have pink shirt.
yes. Now we have the winner of the third place, and the award goes to Humam Ahmed.
Thank you. And we have the award somewhere. Third place, trzecie miejsce. Yeah, this is the third place. Second place.
Okay. Now, now the award for the second place, and the award goes to Ravi Shankar Yadav.
Idź do zdjęcia. The first place.
Yes, and the winner is Patrycja Janiszewska. Menopauza. Menopauza is not pauza.
Proszę, tam. Thank you. Jeszcze tutaj, Ola, jeszcze tutaj mamy zabaweczki. Pani Patrycja taka, och jej, łzy w oczach. Yeah, congrats. And it's not the end.
It's
We still have People's Choice.
okay, and the award for us goes to Magdalena Ćwiertniewicz-Wojciechowska.
Yeah. Tak. May I ask you all guys to stay, and yeah, of course. Please stay with us. We have a photo of this. Wait a minute. Yeah. A co to jeszcze? Za momencik. Yeah. The first photo here. The second will be all finalists. All the finalists should be here. Yeah. Yeah, you should squeeze, I think. Sebastian, ty jesteś wyższy, to stań sobie z tyłu. Tak. O. Yeah. Wystajesz, dobrze jest. Perfect. Yeah. And now please all the finalists join us. And the jury, please join us to have a common photo here. Panie rektorze, się proszę tam teges. Wszyscy są, tak? Pięknie. Jury, all the jury, please. All the jury. Ty się po prostu zgubisz w końcu, dziewczyno. Co ma? Aha, właśnie, Asia jeszcze. Asi nie będzie, to zaraz może się da przepiąć. Dokleimy ją. And actually, it's not the end, because I would like to thank you so much. Joanna, thank you very much for staying with us here. All the jury, all the finalists, all the winners, everyone who's here, the promoters, the guests, thank you very much for coming. I would like to thank you also the co-organizers, the doctoral school and PhD Student Council. And thank you very much for the group of Center of Science Popularization, Ola Wojaczek, Beata Batejko, Dawid Grygiel, Witold Ścieżka and Anna Medoń. And also there is a behind scene with Łukasz Krawiec and Łukasz Romik, who actually supported us technically. And the bottom of my heart, thank you very much. I would like to ask you all to come here. We'll have the common photo. I hope we will see again. Thank you. Zapraszam wszystkich Państwa, all of you guys, everyone. To zostawcie na razie. Potem dam, dobra?
Great job.
Yeah, thank you. Join us. Pani profesor, zapraszam. Grzesiu, chodź tutaj, dziecko, wróć potem.
To the center, please, to the center. Yeah.
Thank you very much, all of you. And the finalists, where are the finalists? We actually forgot to give you also something from us, so please stay for a moment. Thank you very much, everyone. You were absolutely wonderful. Congrats. Mówiłam?